Okay, so these are the third page video for the third page of notes 5.2 trigonometric functions. Okay, so an example. Let's look at example 8. They're telling us that the sine of an angle is 3/5, and the cosine of that same angle theta is negative 4/5. Then we want to find the other four trig ratios. So think about this where sine, first of all, sine is positive, cosine is negative. We should be able to say what quadrant we're in. So we did some examples back in, what example was that? Example 6. Go look at example 6 to help us figure that out. Sine is positive, cosine is negative. Sine is positive in the first and second, sine's positive in the first and second quadrants. So that means we would then say, oh, cosine's negative. Well, cosine's not negative in the first quadrant. So we have to be, these two things tell us that we are in quadrant 2. It's the only quadrant in which sine is positive and cosine is negative. All right, so let's draw a picture then. And if we could draw it to scale, that would be even better. But we're in quadrant 2. Think about sine. Sine is y over r. Cosine is x over r. So if we draw it kind of to scale, it would be better. Draw always down to our x-axis. And so our x is negative 4. Our y is 3. Our r is 5. Okay, so now, the theta that we're talking about is this one. But our reference angle, we haven't really used that term yet, but the reference angle theta in here, now this theta and that theta are not the same theta. So let's maybe do theta prime. We'll put a little apostrophe on that theta. Those two are different angles. They're related, right? In this case, they both sum to 180. But this is the reference angle. And so we're going to pretend that we're looking for the sine, cosine, tangent of that angle. It's really the same as this angle. Okay? So we already know sine, cosine. Let's do, I'm going to put them in the same order, tangent theta, and then cosecant theta, and secant theta. Kind of putting them in the same order. We already know the sine and the cosine. Let's see, we need to do the cotangent theta as well. All right, so the tangent. Remember the tangent is the y over the x. And so what's the y over the x? 3/4, negative 3/4. And then again, the x is negative, but when we make the ratio, we typically put the negative upstairs. So 3 over negative 4, but negative 3/4, or negative 3 over 4. All right, cosecant. Remember that the cosecant, it's really just the reciprocal of sine. So if you want to just look there and say 5 over 3, it's also what? R over y. So 5 over 3. Secant, again, reciprocal of the cosine, so negative 5 over 4. But remember, too, that is r over x. So we take 5 over negative 4, or negative 5/4. And the cotangent, that's the reciprocal of tangent, so negative 4 over 3. Again, that's the x over the r this time, so negative 4/3. All right, example 9. Find secant alpha if the sine of alpha, so alpha is just another Greek letter. Remember, we use a couple of different Greek letters, theta, sometimes alpha. In example 10, you'll see that we're using beta. So alpha, so secant alpha, that's the angle. Sine alpha is negative 1/2. All right, negative 1/2, that means we're either in the third or fourth quadrants. It tells us, in this case, that the terminal side is in the third quadrant. So let's draw a picture. All right, sine, remember sine is y over r. Y over r. So, you're not going to draw it perfectly to scale, but y over r, so we do something like this. Again, we're drawing it always to the x-axis. y is -1, r is 2. We should be able to find that third side using Pythagorean theorem. Although we should know what this reference angle is. This is one of our special right triangles. This should be the square root of 3. All right, and you can see 4 minus 1 is 3, so square root of 3. And so that would make this the 30 degree. So this is one of our 30, 60, 90 right triangles. Those are going to come into play a lot as we go through the next couple of chapters. All right, so now we don't have to find all 6 of them here. All we're asking you to find is what is the secant of alpha. Remember that secant is the reciprocal of cosine. That is r over x. So to help us kind of visualize that. And so that is going to be r is 2 over x, which is the square root of 3. And of course, we don't like to leave it like that. So we'll do 2 square roots of 3 over 3. Now, you have to be careful. They didn't give us the other side, but we know this one, they didn't give us the third side. We found it, but you have to realize that that is negative. And if you don't, then just think about secant, right? All students take calculus. So cosine and secant are the same, right? And so it's positive here, but in the third quadrant, this is negative. So make sure that you put a negative in your answer at the end. It wouldn't be bad to go ahead and put it in, in here as well. Okay, so if you don't remember to put the negative here because you go to the left, so it's negative, make sure that you're checking your all students take calculus to make sure that you're not losing a point for that negative sign. All right, example 10 then. Find cosecant beta if cotangent beta is 4/5, and then it's telling us that beta is between 180 degrees and 270 degrees. So think about which quadrant that is. That, again, is in the third quadrant, so we're down here somewhere. Cotangent, remember cotangent is y over x, so the y is a little smaller than the x. We have 4 and 5, and again, we know these are both negative, so make sure you go and put in those negatives for those. Okay. And then we just need to find the r value. So r is equal to the square root of 25 plus 16. So r is equal to the square root of 41. And then we're asking you to find the cosecant of beta. Remember the cosecant, that is a reciprocal of sine, so that's r over y. Again, got to commit those to memory. And so now we know we can plug stuff in. Square root of 41 over -4. Okay. See, cotangent, I'm just double checking this one. The cotangent is y over x. Yeah, that sounds right. My notes have, I think, the wrong answer in it. I flipped those, but I think here it's correct. Cotangent, the cotangent is the, oh no, I did this wrong. Tangent is, right, cotangent. Tangent of beta, that is, tangent is y over x. So this is x over y. So did I do that wrong? Let me check. Hang on. Yeah, the x is 4. The y is 5. Yeah, I did flip those. Okay, so this is 4, and this is 5. The r is still square root of 41, however. Cotangent x over y. Yep, I goofed on that. So we're looking for, oh, that's the same, but it's just my y should have been 5. So I didn't draw that perfectly to scale either. this one should be a little bit longer, but ultimately it's a tool to help us visualize that. Okay. All right, so some identities. Now, they introduce identities in this section, but we're not going to use them a whole lot. The way they're using them feels a little forced in this section, but it's going to be useful to go ahead and introduce them, and then later on we're going to be more responsive. We're going to have to interact with them a lot more. So for now, don't worry about it too much. But the Pythagorean identities, that means if I take remember we in the last page we had that we write instead of saying sine theta, that quantity squared, we write sine squared theta. It's just the same. It means the same thing, but it's a slightly different notation that means the same thing. So if I take the sine squared of a theta, I take the whole ratio. Again, I'm not squaring the angle. I'm taking the ratio and squaring it. And then I add it to the cosine squared. That will be equal to 1. So sine squared theta plus cosine squared theta is equal to 1. And then tangent squared theta plus 1 is equal to secant squared theta. And 1 plus cotangent squared theta is equal to cosecant squared theta. Okay. Now, there are some alternative forms of this. We could use a little algebra. I could solve this first one for cosine. So cosine squared theta will be equal to 1 minus the sine squared theta. Or I could take this and move the 1 over and say tangent squared theta is equal to secant squared theta minus 1. So I could do a little bit of algebra. We don't think of these as separate identities. These are just algebraic alternatives to the ones that they gave us. Okay. And also remember that the squares are really important. Sine theta plus cosine theta is not equal to 1. So you have to have the squares in there for this to work. It doesn't work without them. All right, and then one more set of identities is what we call the quotient identities. So tangent theta is equal to sine theta over cosine theta, which is kind of easy if you think about to show that. What is sine theta? Sine theta is y over r. And what is cosine theta? It is x over r. So, simple algebra shows us that tangent, which we know is y over x, that is, of course, equal. And you can use a similar logic to kind of show that these are true as well. And, you could do the same thing to show these by putting in your x. So sine, that's y over r, and that's squared, plus x over r for cosine, and that's squared, right? So that, what do we get? We get y squared plus x squared over r squared. And we know from the previous pages that y squared plus x squared, that's just r squared, using the Pythagorean theorem in our triangles. And so that's, of course, equal to, yes, 1. R squared over r squared is 1. And you could use a similar sort of test to verify that those are true as well. All right, let's use our identities. Now, example 11 is a lot like examples 8, 9, and 10 up above. So if you were asked to do this, it would be so much easier to do this one using the same approach. What quadrant are we in? And let's draw a right triangle. But here they're asking us to do it using just our identities that we know. So use the above identities to find cosine theta and tangent theta. Given that sine is negative square root of 2 over 3, and that the cosine of theta is positive. So these can tell us what quadrant we're in, and we could draw a picture like we did up above here. But here again, we're asking you specifically to use your identities. So sine theta, we could use this first identity, right? So sine squared theta, we'll use sine squared theta plus cosine squared theta is equal to 1. And so let's plug in what we know. So we're going to take that ratio, negative square root of 2 over 3, and we're going to square it, plus the cosine squared theta equals 1. So we're going to square this that's going to be 2/9, right? 2 over 9, and it's going to be positive. So that means we could then say 2 over 9 plus the cosine squared theta equals 1. Well, let's turn that 1 into what? 9/9, so that we can combine these. We're going to take this 2/9 to the other side. And so cosine squared theta is equal to 7/9. And so 7/9. And so then what is the cosine of theta? We'll take the square root of both sides. And we're told that the cosine is positive, so we don't have to worry about plus or minus, but it's the square root of 7 over 3. All right, that is what the cosine of theta is. And so we just use the identity to do that rather than drawing the triangle and finding x and y and r and, finding it. All right, so let's try the tangent then. So I know the cosine, so I could use this identity, but I think it'd be easier just to use this one. Tangent theta is equal to sine theta over cosine theta. And so let's plug in what we know here. Tangent theta then is equal to sine, which they gave us, negative square root of 2 over 3 over square root of 7 over 3. And so if we just use, keep, change, flip thing here, right? A fraction divided by another fraction, it's negative square root of 2 over 3 times 3 over the square root of 7. So hopefully at some point you don't have to do this step that we learned in middle school. We can say, oh, this 3 cancels with this 3, and simply gives us negative square root of 2 over square root of 7. Of course, we have to multiply square root of 7 and square root of 7. And so that's negative square root of 14 over 7. We would like it to be, no radicals in the denominator. So, okay. So those are our two answers in that case. Again, we're just using identities. Same type of problem as 8, 9, and 10, but they want us to specifically use the identities. Okay. Use the above identities to find the sine theta, cosine theta, given that the cotangent theta is equal to negative 7 over 24. So I guess I would maybe think about using, let's say, we can use this identity, right? We're given cotangent. Why not maybe use this identity? Let's just try that. So we have 1 plus the cotangent. Well, let me write it out first. Cotangent, so you can clearly see what identity I'm using, equals cosecant squared theta. All right, and now let's plug in what we know. So I'm going to write this as 24 over 24 plus a negative 7 over 24. We'll want to square everything, though. So actually, that would be the wrong thing to use. I'm going to square this. Let's leave it as 1 for now. Square that equals cosecant squared theta. When I square that, that's, let's do this one first. That's going to be 49 over 576. 576. So let's make this 576 over 576. That would make more sense. And that's equal to cosecant squared theta. Sorry, didn't realize that was off the bottom there. And so when we add those up, that becomes 625 over 576, and that's equal to cosecant squared theta. These are both perfect squares, so that's nice. We're in quadrant 2, so I know this is going to be positive. So I take the square root of both sides, second quadrant, so this is just the positive. So cosecant theta is simply equal to 25 over 24. So, of course, we weren't asked to find the cosecant, we're asked to find the sine, so we simply do the reciprocal using our reciprocal identity. Sine theta equals 24 over 25. Okay. multiply. So that's the sine, and then cosine. Let's use this identity, right? We now know the sine. We also know the cotangent. They gave that to us. So negative 7 over, well, let's write out the identity first. The cotangent theta equals the cosine theta over sine theta. And let's plug in now what we know. So we have negative 7 over 24 equals cosine theta times the sine, which is 24 over 25. And then we're going to multiply both sides by 24 over 25. So that should give us cosine theta is equal to, the 24s would cancel, negative 7 over 25. Okay. So again, these are a little bit more cumbersome to do using the identities rather than just drawing a picture. So if they don't tell us what method to use, I probably wouldn't use identities to solve these. I would just draw a picture, figure out which quadrant I'm in, use my sine of theta. Okay, that's y over r. Draw a right triangle up to the x-axis. That would probably be the easier method. But here they're just asking us to practice these identities. I don't know that on a quiz or test I would just give this to you, and you could use the identities, or you could just draw a triangle on sort of the unit circle type thing. Totally up to you. All right. And then here is the homework. Some of these are asking you to use the identities, so you might as well practice some of your identities and use them to do some of this. All right, so this homework is the homework that is due next class.